Hi everyone, this is Sai Charan. Today I am going to do concept video on topic importance of quantum mechanics in engineering. In this presentation I am going to present about quantum mechanics. What are quantum numbers? A electronics unique fingerprint that describes its position and behavior. Quantum mechanics is equals to explains the behavior of very small fast moving objects. Quantum mechanics overview. We will see electrons have discrete energies not because they are in shells but because they cannot only have certain wavelengths. Line spectra are not due to the electrons jumping from shell to shell as in the Bohr model. Instead, they were due to electrons transforming from one wavelength waveform to another wave electron is the wave that can be described by the series of quantum numbers. There are four quantum numbers n, n, m, ml, and ms. The combination of first three defines an orbital. Classifying electron waves. The waves of electrons are similarly classified according to certain variables n, l, m, suffix l. The rationale of the numbers is not always clear. These numbers come from some pretty advanced math. You do not have to know why we use certain formulas for determining quantum numbers. You do have know what the formulas, when to use them, and what are resulting quantum numbers represent. Quantum numbers. There are four numbers that come into the theory of electron clouds as waves called quantum numbers. The first quantum number n is the principal energy level. This is the one is 1s. It can have the values 1, 2, 3 up to so on. The second quantum number is L is the sublevel. The nth principal energy level has n subshells. We refer to these sublevels by letters S, P, D, F, G, H, I, J, K up to 7. Sometimes numbers are used to 0, 1, 2, 3 up to so on n minus 1. L, the second quantum number. Easy value of L is associated with a letter 0 is equals to S, 1 is equals to P, 2 is equals to D, 3 is equals to F. After 3, the associated letters go alphabetically from F up to 4 is equals to G, 5 is equals to H, etc. Normally we don't talk about electrons beyond L3, the F subshell, whereas N represents size and energy. L tells us of the shape sublevel of an electron. More detail later. We oftenly identify electrons by shell and subshell. Example 1s, 3d, 2s, and 5d subshell. L, the secondary quantum number. If n can be a thought as a shell, L can be a thought of an subshells. Dividing each shell into subsections, L is equals to 0, then n minus 1. You can observe given figure. N is equals to 1, L is equals to 0 of S. Then n is equals to 2, L is equals to 0 in S orbital, L is equal to 1 in P orbital. Then n is equals to 3, L is equals to 0, S, L is equals to 1 of P. L is equals to 2 of D. Use quantum number as study tool. Quantum numbers. The third quantum number ml is the orbital. Every subshell has one or more orbitals. The s subshell has one orbital. The p subshell has three orbitals. The d subshell has 5 orbitals, etc. These orbitals can be indicated by the number ml is equals to l minus 1 up to so on 0 minus 1 to up to minus 1. The fourth quantum number m suffix s is the spin of the electron. Electrons can be either spin up or spin down. M suffix s can be either plus of or minus of. Principal quantum number n is equals to 1, 2, 3 up to so on. Related to the size of the atomic orbital, means distance from the nucleus. Larger n value indicates higher energy. Larger n value means electrons are less strongly bound to the nucleus. Angular momentum subshell quantum number L is equals to 0 to n minus 1. Relative to shape of the atomic orbital. Value of L 0, 1, 2, 3, 4. Letter used S, P, D, F, G. N is equals to 3. L is equals to 0, 1, 2. S, P and D orbitals in third shell. Magnetic quantum number M suffix L is equals to L 2 up to minus L. L to minus L. Relatives to orientation of the orbital in space relatively to other orbitals. Second, from L is equals to ml is equals to minus 2, minus 1, 0, 1, 2, 5 d orbitals. Electron spin quantum number m suffix is equals to plus of to minus of. Relatives to spin states of the electrons are minus 1 charged and are spinned. Spinning charge creates a magnetic field. Fourth, you can tell the direction of spin by which way the magnetic moment lines up in an external magnetic field. Pauli exclusion principle. In a given atom, no two electrons can have the same yet of 4 quantum numbers n, l, m suffix l, m suffix s. Second, therefore, an orbital can hold only 2 electrons and they must have opposite spins. Third one, electrons can have the same n, l, and m values. A. N is equals to 3, L is equals to 2, d orbital. M is equals to minus 2, a single d orbital. The single d orbital can be only hold 2 electrons, one with m suffix s is equals to plus of and the one with m suffix s is equals to minus of. You can observe the given table quantum numbers for the first 4 levels of orbitals in the hydrogen atom. N and L electronic configuration or orbital distribution. M suffix L. Number of orbitals. You can see in order 1, 2, 3, 4 and L 0, 0, 1, 0, 1, 2, 0, 1, 2, 3. And then you can observe that electronic configuration is 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f. And M suffix L 0, 0, minus 1 to 0 plus 1, 0, 0 minus 1 plus 1, 0 minus 1 minus 2 and 1 2, 0, 0 minus 1 1, 0 minus 1 minus 2 1 2 and 1 minus 1 minus 2 minus 3, 0 1 2 3. And then you can observe that number of orbitals 1 1 3 1 3 5 1 3 5 7. Second, orbital shapes and energy. Atomic orbital shapes are surfaces that surrounded 90% of the total where electrons are. First one, look at L is equals to 0 and the s orbital. Second, basic shape of an s orbital. Third, centered on the nucleus. Third, basic shape in the same nodes is equal to area of 0 probability. Third, number of nodes charges. We will usually just use outer to describe the shape of an orbital. 1s, 2s, 3s. You can observe that size of the nucleus increases. P orbital. There are number of 1p orbitals, n is equals to 1, L is equals to 0 only. 2p orbitals, n is equals to 2, L is equals to 1, have two lobbies with a node at a nucleus. There are three different p orbitals, L is equals to 1, m suffix L is equal to minus 1, 0, comma 1. 2px lies along with the x-axis, 2py lies along the y-axis. You can observe that 2px, 2py and 2pz. They are the three axes. D orbitals. There are number of 1d or 2d orbitals. D needs L is equals to 1, so n is equals to 3. 5d determine d orbitals. m1 is equals to 0, minus 1, minus 2, 1, 2. 4 of the d orbitals have 4 lobbies which lie in the planes on or between the xyz axis 3d xy. You can observe that dx y, dx z, dx x and dx square minus y square, dz square. F orbitals. N is equals to 4, L is equals to 3, m suffix L is equals to minus 3, minus 2, minus 1, 0, 1, 2, 3. 7f orbitals in the fourth shell are the degenerative. The f orbital are the only used for the lanthanide series, and you can observe that. Orbital energy. Orbital energies are largely determined values of n 3 greater than 2, 2 greater than the for H atom. But for polyelectron atoms the differential L values are not all generative. S not equals to S. 2s is the larger than 2p orbital. 3d up to so on the 2 orbital is so is the lower. You can observe the given table. Radical probability and the distance from the nucleus, penetration 3s, 3p, 3d levels. The history of the periodic table. Patterns in the element properties were recognized. Dolbear 1782-1849 found traits of the similar elements chloron, boron, iodine. New Ireland suggested in the 1984 that elements should be arranged in the octaves because similarities occurred every eighth element. Properties of, you can observe the periodic modern table. Properties of germanium predicted and observed in 1896. So you can observe that atomic weight, density, specific heat, melting point, oxide formula, oxide density, chloride formula, BD of the chloride. Hund's rule. Orbital of equal energy are the each occupied by one electron before an electron is occupied by second electron. All electrons in a single occupied orbital must have the same spin. Let us summarize the quantum numbers. Principal quantum number symbol is equals to n. Repetitions. The main energy level of the electron range is equals to 1 to 7. Example 3s. The principal quantum number is 3. Angular momentum, quantum numbers, symbol is equals to L. Smaller letter L represent the shape of the orbital, also called sublevel. Range 1 is equals to n minus 1 whole number. Shapes 0 is equals to S sphere, 1 is equals to P petal, 2 is equals to D double petal, 3 is equals to F flower. Magnetic quantum number, symbol M, represent the orientation of the orbital around the nucleus. Each line holds 2 electrons. You can observe 0 is equal to S, minus 1 0 plus 1 is equals to P. Magnetic quantum number constant, minus 2 minus 1 0 plus 1 plus 2 is equals to D, minus 3 minus 2 minus 1 0 plus 1 plus 2 plus 3 is equals to F orbital. So that the M suffixes are the just S, the spin clockwise or the counterclockwise or the electron. It describes which of the two possibles. Electrons in the any orbital is being described plus of spin quantum number 2 spin states clockwise spin plus of upward arrow, counterclockwise spin is equals to minus of downward arrow. A single orbital can hold 2 electrons but they must have opposite spins. Thank you. By that I will end my presentation. Thank you everyone.